Hey, it's Miss Lee here, and I'm going to show you how an electrochemical cell works. That's just a fancy word for a battery. All right, so here we have two electrodes. Electrodes are basically just metal strips. We have zinc and we have copper, and we want to figure out who's going to get oxidized, who's going to get reduced. To do that, you're going to consult your table J, right? And you should see that zinc is higher than copper. So zinc's going to be the one that gets oxidized, copper's the one that's going to get reduced. So let's see how this works and how this applies to an electrochemical cell. To do this, we're going to take the copper metal, we're going to put it into a solution of copper ions, right? They won't react all by themselves because copper really won't replace itself. It's just a no reaction. Here we have the zinc. We're going to put the zinc in a solution of zinc ions, so they won't react. So right now there's no reduction, there's no oxidation happening at this point in time. What we're going to do to see if we can get the electrons to flow, we're going to hook it up to this voltmeter. We have this black wire, which we are going to hook up to the zinc. And we have this red wire, which we're going to hook up to the copper. And right now, we see that there is no electricity flowing. The needle is not moved on the voltmeter. And that's because we have not completed the circuit. These two cells have to complete the circuit. We're going to do that by taking what is called a salt bridge. This is really just salt water. It's sodium chloride mixed with water. It's not going to interfere with either of the reactions. It's just going to help us conduct the charge. So really I have this soaked piece of paper towel, and when we put it between the two half cells, you should see that the needle on the voltmeter moves right here. So now we can see that there is electricity flowing. So let's take a look and see what's actually happened. We said that the zinc is the one being oxidized. It's losing electrons. Where are those electrons going? They're going out through this black wire. So when the zinc loses the electrons, two things happen. The electrons go through this wire, and the zinc ions that are left dissolve into the solution here, which already has zinc ions in it. So let's follow that path of electrons. The electrons go out through the black wire, they come around through the load. In this case, the load is the voltmeter. The electrons come out through the red wire, and they end up at this copper electrode right here. So the copper electrode is piling up with negative electrons. So those negative electrons are attracting these copper ions that are in this blue solution. The copper ions migrate over to the copper electrode, and they then get reduced. So those copper ions are turning into copper atoms. This copper metal should get heavier because it's going to be coated with copper. The zinc, in the meantime, is going to dissolve because it's being oxidized. The zinc atoms are turning into zinc ions. And so eventually this strip of zinc metal where it's in the solution is going to just be completely dissolved away. The purpose of the salt bridge is for ion flow, because as we use up the copper ions, the positive ions that are in the salt bridge will flow here to balance out that, counteract that change in the charge of the solution. And over here, the negative ions are going to flow in this direction to counter effect the positive ions that are going into this solution. So really a battery is nothing more than taking a redox reaction. The two half reactions, the oxidation half and the reduction half, get separated, and we want to separate them so we can harness those electrons, because if you can move electrons through a wire, you can power your portable devices. All right. Next video you're going to see, we're going to actually label a diagram of this, and we'll do a lot more with labeling who's the anode, who's the cathode, who's the positive terminal, who's the negative terminal, all that stuff. But this is basically what an electrochemical cell can do. You've already learned how to calculate the voltage from your AE table D. So you don't actually have to hook this up to get the voltage. You can determine it from your table D. All right, that's it for now. We'll see you in the classroom.